So my research focuses on the field of experimental particle physics, and in particular on studying the properties of a special particle that we call the Higgs boson. It's considered to be the physical manifestation of what we call the Higgs field, which according to our theories is in turn related to the mechanism that gives mass to most of the fundamental particles that we know. We think that the Higgs field permeates the whole universe, and the fundamental particles acquire a mass by simply interacting with it. And the value of this mass is directly proportional to the strength of their interaction with the Higgs field. So in principle, this is a very simple concept, but there are some issues. So for example, we are not able to explain why a given particle has the mass that we measure. And even more interesting, we're not able to explain why the particles that make up matter, which we call fermions, seem to be organized into 3 different generations. So of course, when our theories fail us in a way, we turn to experiments. We can hopefully find insights about where our theories should go next. My research is focused on studying the decay of a Higgs boson into 2 muons. This is a very simple research in a way, because we only want to look at these 2 particles, and we want to study their mass distribution. And if these 2 particles were produced by a Higgs boson in the first place, then we would see a peak in the mass distribution that corresponds to the mass of the Higgs boson, which at this point is known. But of course, things are a bit more complicated than that. The main problem in this case is that this process is very rare. It's very unlikely for us to observe it. And on the other hand, to make things even worse, we also have a lot of different processes that might give rise to 2 muons as well, but they do not originate from a Higgs boson, a background noise that does not allow us to see what we're looking for properly. So our main challenge is to reduce to the minimum this background contribution, and on the other hand, to increase or maximize the number of signal events that we are looking for. So with the data that we collected until now, we were still not able to directly observe this peak. So we cannot say anything for certain about this process yet. But at the same time, we were able to reduce by a lot the uncertainty that we have on this process. We have hints that point towards the fact that this process will behave according to what our theories predict. This work, of course, lays the foundations that will allow us or allow future scientists to certainly and with enough confidence draw conclusive information about this process.